All right, first things first, look here. This is the test. As always, to show it to you, there's no backside. It's all problems. There's no multiple choice, no matching, no short answers. There are 5 word problems like these. There were 3 on the review. There is the same kind of chart here, only with the limiting reactant one in it as well. Going to go over that at the very end. I didn't put it on the board here. Not enough room, but I will do one at the very end today. That's it. That's the entire test. On the back, there will be an extra credit one, and we'll talk about it. I won't really talk about that one, but there will be an extra credit one on the back that I hinted at in the past. All right. Let's do this. I'll use green because it shows up better on the blackboard. First thing I got to do is complete this equation. Let's remind you some of the basic stuff you got to remember about writing compounds. I have a lot of people who will do stuff like this. Cu plus 2, NO3 minus 1, Al plus 3, CO3, look it up, minus 2. And they'll go through this whole process and never use them. Okay? That's nothing. It's useless. You wasted all your time. You may as well just written them out without even looking up the charges. You've got a plus 2, minus 1, you got to put a 2 there. Plus 3, minus 2, you need a 2 there and a 3 there. Plus 2, minus 2, it's okay. 3 and 1, you need a 3 there. Now I got to balance them. How do I balance this? Well, I've got 3 nitrates here. I've got 2 nitrates there. Going to need, see what I'm saying here? 3 of them here, 2 of these guys here. I'll need a 2 here, and I'll need a 3 there. See it? Now, I also messed up my copper in the process, so I'll put a 3 there. That takes care of my carbonates, because there are 3 already over there. All set. Did you all get that balance right? Okay. If you didn't, of course, you'd have a hard time doing the rest of this. None of them would be right, because the coefficients would be wrong. All right, now, once you've done this, you want to look for the easiest way out. The coefficients tell you the mole ratio. This guy going to here may not be quite as easy. What's the easiest one to do? Right? This guy? I mean, it's the exact same coefficient. These 2 columns will be identical. 3 is to 3 as 6 is to 6. It's the exact same thing, right? We've been doing these since last Monday. That's over a week. No one, and every day I did one except for the day of the lab. I did a chart like this every single day. So there's really no excuse. Not, where are you getting that from? All right. Now look at 3 goes to 1. This guy's 1/3 the size of him. 6. What's 1/3 the size of 6? 2.0. Now let's just. I'm going to leave out the units from now on to save some time. But let's say you can't see it though. What are you going to do? You just do a conversion like you would do in the middle of one of these problems. Just write down your 6.0 moles of that, moles in the bottom, moles in the top, and use the coefficients like I showed you a couple of times. But most of these you will be able to see in your head. All right. This guy is a 1. This is what I'm talking about using your finding the easiest way out. This guy's a 1. I'm going to go to this guy's a 2. See, that's the easiest way to go. This guy's 1. This guy's twice as big. That's 2. This must be 4. See it? Everybody got that? All right. Now, a little faster on this next one. Once again, I've got 3 here. I've got 3 there. So if that's a 2, this is a 2. I'm leaving out the units. You should not. You should also keep significant figures, which I am. This guy is a 1 versus a 3. So this guy's 1/3 the size of that. What's 1/3 the size of 2?
0.67.
0.666 repeating or 0.67. Sure. And then this guy's twice the size. What's twice the size of 0.666 repeating? 1.333 repeating, which would be 1.3. Right? What we got? All right. This guy here is a 1. And he is twice as big as that guy over there, so he must be a 0.5. Once I know he's 0.5, and he's 3 times as big, 3 times 0.5 is 1.5. And once I know he's 1.5, I know he's 1.5. So that's how you do this. Okay? It's pretty simple. The coefficients tell you the ratio, the mole ratio. Now, we're going to do the same basic idea down here in every one of those, but we're going to actually write it out as a conversion. Let's do it. And I'm going to remind you of how I want you to look at these. Those of you who love to get lost in the middle of word problems, like I said at the beginning of this chapter, let's see what we can do to avoid that. I break it down. First time I read this, what am I going to look at? What words tell me about the equation here? 3 words, basically. What words tell me how to write this equation? First person I know I'm going to call on is going to say aluminum sulfide is produced. No, it's not. Not important. What's important? What's the bare minimum I need, Josh?
Reaction of aluminum.
Reaction of aluminum
Sulfur.
and sulfur. That's all I need to know. And I'm going to shorten things up so I can fit it into this review here. I'm not going to put the words out. You should write aluminum plus sulfur. I'm just going to shorten up by Al plus S yields. Okay, you could write the aluminum plus sulfur though. Okay, Al plus S yields ALS. And of course, if I don't use the charges, I'll be wrong. Plus 3 for him, minus 2 for him, 2 and 3 there. And then the coefficients. 3 there and 2 there. That's an AL. Okay? There we go with that. Second time I look at the problem, I want to know how to begin it. I want to know what to write down. If you leave these blank, people, you're getting minus 15 on average. Like I said, these will range from 12 to 18 to maybe even 20 points depending on the problem. You can't just leave it blank. You've got to read it, get it correct. By the way, notice how I have this written. I'll bet some people, because again, they read from left to right, wrote down aluminum sulfide yields. I saw that in the worksheet all the time. Stuff like that. It's not aluminum sulfide yields. You'll lose points for that, even though your answer will come out to be right anyway. It's aluminum plus sulfur yields, because it tells you it's the reaction of aluminum with sulfur. All right, second time I read, I'm looking for how to begin the problem. Here's how I begin the problem. 2.4 moles of sulfur begins that problem. So I write down 2.4 moles of S. Now, some of you who think you're smarter than me, and you very well may be, think, well, I can just see that. Can I just put the answer down? No. Any word problem, I need to see the conversions. I notice in the homework, there's a lot of lacking work. I only took off for 11, 13, and 15 because those ones you couldn't do without showing me the work. Other ones that you could have done in your head, I still want to see the work. You can't skip this step because, I can see that in my head. Need to show moles in the bottom of sulfur. And then I look up for the last time and I see who am I looking for? I'm looking for aluminum sulfide. So moles of aluminum sulfide on the top. And I fill that in with the coefficients. Now you realize coefficient of Al is 1, coefficient of S is a 3. You realize this is exactly what you were doing in your head just a minute ago on that chart. Only here we're physically doing it, like calculating it. 2.4 divided by 3, I believe you get 0.80 moles. Is that right? Everybody get that? I hope. Good. All right. Next one. If 10 moles of iron react with lead nitrate, and there it is, that tells me what I need to know right there, right? Iron reacts with lead nitrate. Now again, you would write the words out, but I'm going to just write out the formulas to save myself some time. Fe plus Pb and J sandwiches. Plus 2 minus 1 yields. Lead nitrate, right? Lead 2 nitrate, right? Okay. What happens in this reaction? Let's take a look at this. Some people will get confused. I don't know what happens. When did I teach you how to do reactions like this? Before Christmas, using the common ion sheet. It's a replacement reaction. So I have FeNO3, that is a 3 there, and this time since he's iron 3, he's a plus 3 minus 1 is FeNO3 3, and lead over here. Hey, I haven't had any, I realize this at the end, I don't think I had any that have diatomic elements in them. You know, we had a ton of those over the course of this chapter and the last. Let's not forget that if I have oxygen or chlorine or hydrogen in here, you've got to write out the 2. You have to write a subscript of 2 for the diatomic elements. Let's not forget that because that will also cost you an imbalance. All right. Balancing this guy, 2 there, 3 there, 2 there, and 3 there. Everybody good with that? Y'all get that? I hope. Emily, you don't look like you're liking that. Is that what you have? Okay. All right, good. Now, second time I read it, I look for the words, the numbers, 10 moles of iron. So I write down 10.0 moles of iron. And I begin my conversion. Now, I could be lost. I could be confused. But I know one thing from chapter 1 on. What units have to go on the bottom? Moles of iron. I know that because I've been teaching it. We've been doing conversions like this forever. Now, you may be confused with what goes on the top, but at least you can start it out. And now I have to read again. And I read up there the last time, who am I looking for? I'm looking for mass of lead. Well, there he is, lead. Now, I know some people will go right to grams of lead there because it says grams of lead or it says mass of lead. You can't do that. There's no relationship between the moles of iron and the mass of lead. There is a very obvious relationship between the moles of iron and the moles of lead. It is 2 to 3. Okay? Oops, I should use green again. Moles of lead. Lead's coefficient is a 3, iron's is a 2. Now, I could be done if this question had just said how many moles of lead instead of the mass. So it doesn't, so I have to actually do one more step. I have moles of lead here. I've got to convert that to grams of lead. 1 mole contains how many grams of lead? What are you going to need? What is it?
207.2.
207.2. Hey, couple of mistakes at this point that I see all the time. Number 1, lead. His coefficient is 3. People put a 3 there for underneath this. When you're going from moles to grams or grams to moles, are you ever going to use a coefficient? No. Secondly, they use this 3 and multiply it by the molar mass. No. Look if I were doing the molar mass of this guy right here in a conversion, everybody look at this. If I were doing this guy right here in a conversion from grams to moles or moles to grams, how many O's would there be? I'd have to multiply this 2 times 3, this 2 times, I have 2 N's, and I'd have 1 PV. I would not then multiply it all by 3. Where is the only place I use the coefficients? In the stoichiometry step. As a matter of fact, this is the only new step in the entire process of anything I've taught you this chapter. What's your final answer for that guy when you multiply it out? Anyway, just yell it out. Somebody? Bo, go ahead.
3,110.
That's correct, I believe. Grams of lead. Okay? How many got that? All right. See, you were all scared. You're right. All right. Last one. 3,110. Last one, people. Y'all watch it? Take a look. Words that tell me about the equation. Very simple. Calcium hydroxide decomposes. That's all I need to know. Calcium hydroxide decomposes. That tells me everything I need to know. Here's calcium hydroxide. And here he is a +2, -1. And here he is decomposing. What does he decompose into? I don't need to look at the problem. I just need to look at the common ion sheet. He decomposes into calcium oxide plus water. Now, will it happen? Is it possible to happen that it won't even need the balancing equation? Does this guy need to be balanced? No. So the coefficients are all going to be 1. Does that mean I don't have to do the middle step? No. You still have to show me that step. I have to know how it got from moles to moles. Okay. Second time I look up there, 37.85 grams of calcium oxide. Do that. 37.85 grams of calcium oxide times. And I have to, especially in a guy like this that's going to go from grams to grams. I'm going to have multiple conversions. I really want to write down who it is I'm talking about. Grams of calcium oxide, and especially in this one where they're so similar. Calcium oxide versus calcium hydroxide, they even look alike, they even sound alike. So grams of calcium oxide go on the bottom. I have to go, I know some people will do it, they'll go directly to grams of calcium hydroxide. You know what? That is a killer. Let me tell you why. You'll get the right answer. You realize I could actually go from grams of calcium oxide to grams of calcium hydroxide, but I will still take off 5 points for that because it is skipping an entire step. There is no relationship between these two, except for the fact that they happen to have coefficients of 1, but that does not happen most of the time. All right, so I go to grams of calcium hydroxide, moles of calcium oxide. Okay, 1 mole contains how many grams of calcium oxide? You look at the molar mass of what is it? 50-something, 56 or something?
56.079.
All right, and now I have to show this work. Moles of calcium oxide go on the bottom. Remember, I'm trying to keep this stuff straight in my head. To moles of what I'm looking for, I look up the last time, I'm looking for calcium hydroxide. So moles of calcium hydroxide on the top. Coefficients of both of those are 1. So yeah, you're right, it won't change your answer, but you have to do it. And finally, moles of calcium hydroxide. It would be done at this point, except that it wants grams. So moles of calcium hydroxide on the bottom, and grams of calcium hydroxide on the top. 1 mole contains how many grams? What do you guys do for that? 70 something?
74.
I'm glad to hear that. It's the second class in a row I heard 58 or something like that. That's really bad, guys. Calcium, here's how they got 58. They took when they had the molar mass, they took 1 calcium, 1 oxygen, and 2 hydrogens. That's how they got 58. That's not correct. How many O's are there in here? 2. And 2 H's and 1 Ca, which is what, 74 point whatever. All right. When you do the math for all that, what do you get for your final answer? All the acid bottles are there, but I don't. I have some acid you could use, but I don't have them filled up. Oh, good. We just did a lab in Chem 2. I used all the acid up.
I don't know.
What'd you guys get for the answer? 50.01. Anybody else get that? And that would be in grams of calcium hydroxide. All right, last thing, real quick, because the bell's going to ring. I want you to be able to take a break, but I need last thing here, people. You will see a problem like this in the test as well. This is not going to be extra credit. This will not be extra credit. It will be on the test. I just didn't have room to fit it on there. Take a look. I want to talk about it, and I wanted to talk about it separately. If I gave you a problem like that, and I asked you who's the limiting reactant, in other words, we mix together 7 moles of ammonia, 6 moles of oxygen, what would my limiting reactant actually be? What will you have to do in this case? What do you think?
Divide the moles by the coefficient.
Yeah, so 6 divided by 3 is 2, right? And 7 divided by 4 is like 1.7 or 8 or what like that. Okay, so let's just say it's 1.8. I don't know. It doesn't really matter. The point is, what matters about that? The smaller of the 2 is your limiting reactant. Now, here we know he's the smaller of the 2. What does that tell me? That's the one we use. We use this guy and not him. We ignore him. Now, to do the rest of the problem, 4 is the 2. This guy's half as big. If he's 7, he's what? 3.5. And that guy's 3 times as big, which would make him what? I think 10.5. Which for significant figures, I would have to round to 11. So that's why I got to be careful. I write the number. That's why you got to be careful about how many significant figures to give you in a problem. All right, good enough. You'll also have a bonus one that will include probably a lot of other little things in there. Molecules, atoms, limiting reactant, all thrown together into one problem in a big long conversion. Maybe even something else I haven't talked about. But I'm not going to go over one. That's why.